Today on Maths is Fun, I'm going to talk about standard deviations. That's a really overly complicated term that just means the average distance away from the average that each data point is. And if you've ever heard the expression, I'm being graded on a curve, they're using a standard deviation to do that. So what they're doing is they're taking the average results of a test, and then they're seeing how far away everyone is from the average, and then they're normalizing the data so that say people who might not have got a passing mark, might not have got over 50%, but if a lot of people didn't get over 50%, they normalize the data to say, well, how far away is everyone from the average? And then they work it out that way. That's what grading on a curve means. And all it's telling you is that in a normal set of data like this here, how far away is all the data from each other. And with a standard deviation, you find that within -1 and 1 standard deviation either side of the average, you'll find something like 68% of the data will fall into that bucket. And then over here, if it's within 2 standard deviations either side, it's about 95%. And if you include the 3rd standard deviation here, it's something like 99.7% of all data will sit somewhere inside of that. There's a huge amount of uses for standard deviations. And let's look at the formula now, because it's kind of horrific, but it's not too difficult if you can understand it. So we're going to go through how this formula works. But the symbol for a standard deviation is this weird circle with a little lip on it, equals the square root of the sum of xi minus x bar squared over the number of values. Right? So it's a pretty horrible looking formula, but we're going to work it out right here on this whiteboard because it's actually really, really easy. So over here I've got some data. You can see here I've got a range of values, and you can see the average of that is 8. So what I'm going to do is I'm going to look at what the distance is of each of these values is from that average. So you can see here this is a 9, so the distance here is 1. This is a 11, so the distance here is 3. This here is 13, so the distance here is a 5. This here is 10, so the distance from the average is 2. This one here is 5, so the distance here is -3. This is a 2, so it's -6. This is a 6, so it's -2, and then this is 0 because it's on the average. So what we're going to do is we're going to plug all of these values into this formula here, because that's what this bit of the formula means. For every x value, which is every point I've got, that's what the xi means. I'm going to minus it from the average. So this is x bar, that means average. There's a couple of different symbols for average, but this is the one I'm using. So I'm going to take away each value from the average. Well, I've just done that. Now, why am I squaring it? Well, that's just a really simple trick, actually. In maths, if we want to get rid of a negative, the easiest way to do that is to square it and then square root it, which is exactly what this formula is doing here. We're going to square it just to get rid of the negatives, and then we're going to square root it to bring our data back to the right number. And the reason we have to do this is that I'm going to add all these together, and if I add positives and negatives, they're kind of going to cancel each other out. And I don't want them to cancel each other out, because I'm not really interested that this is -3. I'm more interested that it is 3 away from the average. This is 3 away from the average. See, these two would cancel each other out, but they shouldn't, because they're both 3 away from the average. So what I'm going to do is I'm going to plug all these values in. So we're going to do this bit of the formula here. We've already minused it. We're going to square each of them. So over here I've got 1 squared is 1, plus 3 squared, which is 9, plus 5 squared, which is 25, plus 2 squared, which is 4, plus -3 squared, which is 9, plus -6 squared, which is 36, plus -2 squared, which is 4, plus 0 squared, which is 0. and I'm adding them all together. That's what this formula here means. Just means sum. So we've already done this bit of the formula here. Now we're going to divide it by the number of data points we have, which we've got 1, 2, 3, 4, 5, 6, 7, 8. So we're going to divide that by 8. And then we need to square root the answer, because we've squared all these values in here. So we need to bring it back to what it should look like. So that then equals 88. So that's 88 over 8 square root. And that equals 11 square root. And that equals 3.3. So we've just done this really complicated formula here, and we've just had a look at this data here, and it's telling us that all of these data points, the average distance each data point is away from the average itself is 3.3. So one standard deviation is going to be 3.3 above 8 and 3.3 below 8, which we could actually put on here. So we can go, here's 8, 9, 10, 11.3. So that's one standard deviation there. And we can do the same here, it's about there. So that's one standard deviation there. And you can see that probably about 68% of those data points are falling within there. The second standard deviation would be somewhere up here, and the third one would be down here and up here. So that standard deviations is really not hard, but you just need to understand the language of mathematics. It looks like a really complicated formula, but it really isn't. I hope you've enjoyed the video.